Alrighty, welcome to another episode of Ben Helps Student Problems. It's been quite some time since I last streamed, mostly because I haven't had any students, but I got some again, so that's awesome. And this first week of class, actually, I noticed that we were struggling a little bit with kind of how things are pulled together in the Java language, and somewhat with syntax as well. But I thought I might want to cover kind of properties that objects can have and what objects are in general. And one of the best tools I've come across that illustrates objects, instances of classes, is Greenfoot. Greenfoot is some of you have been to my Flappy Bird crash course where I build Flappy Bird in front of a group full of students, a group full of, just people. And the reason why I do that is because, Flappy Bird's a pretty simplistic game, first of all. It's pretty easy to implement the logic. Second of all, just Greenfoot in general is designed to be approachable from a basic user standpoint. So here we are inside Greenfoot. I'll just show you the end product right here. We're not going to do the whole thing right now. Oops, I lost. So you see, oh god, I lost again. All right, so we have a Flappy Bird. If you look closely, he is flapping his wings, and he's flying up and down. The pipes are going up and I ran into that thing. So I scored 12. That's good. All right. I promise I'm good at this actual game. I'm gonna try and get 15. Let's see if I can get 15. Should display a running. Nope, 6. All right, I give up. So. This is pretty cool. This took about 3 or 4 hours of coding inside Greenfoot, including the time spent in the crash course. So Greenfoot really makes it easy. I mean, if you were to do this without Greenfoot, it would be a lot longer than that. But since we're using Greenfoot, it gives you lots of utilities to create graphics and stuff like that. So over here on the right, we have a series of classes. So we haven't covered this thing called extension yet, but we'll get to that later. We have a class here called My World. We also have a bunch of classes called Flappy Bird, Game Over, and we have Bottom Tube and Top Tube, right? Now, when you make a new class inside Greenfoot, this is just like a class that we've covered before in class. No pun intended. So let's just say we have, if we want to make a hamburger class, let's go over here and do hamburger. Now, the cool part about Greenfoot is that it assigns this visualization to hamburger. It's this icon. So when hamburger exists in the world, which we can do if we right-click this and do new hamburger, we can put it in the world. Now, objects in the world, and we can have the bird look like he's about to eat the hamburger. That'd be fun. This is a cheeseburger. That is... Maybe the image did say cheeseburger. Maybe I was just incorrect about that. Anyway, so this actor in this world has a position. There's an X and Y position. There's a rotation of these images. We can move them around. If we right-click... Got my daughter trying to join in on the action here. If we right-click on this guy, we can see all of the things that this hamburger can do, right? We can get, we can move him. So this is the same as calling hamburger.move. So this is going to move him. I don't know the parameters that move can take. Maybe 50. Let's try that. Okay, so moved him over in the x-axis by 50 pixels. All right. And so you can see that it wouldn't make sense to right-click this and run those methods here because those aren't objects of the hamburger class. We have to have the object existing. And you can kind of see, it makes it look like the code itself. So int get rotation, we just ran that code. You can think of this as the getter. It returns 0 here. Now, if we want to go here and we want to call set rotation, we say, I think it's clockwise. Yeah, we just rotated I'm pretty sure, yeah, we just rotated the cheeseburger clockwise. And if we run that again, we call get rotation, we see that it's 90. So that rotation field, hold on one second, let's shut the door. So that rotation field exists inside the hamburger object, but we don't have access directly to that field. We can retrieve it and we can set it with these values. So let's set the rotation to something crazy like this big number. See what happens. Well, it still worked. Probably it's doing some math to make it work. So that's probably what's going on there. So that wasn't super helpful. Let's see. You can see all the things that a cheeseburger can do. These are instance methods, right? So this cheeseburger here is an instance of cheeseburger. So if I have a new cheeseburger here, I got 2 cheeseburgers in the screen now. If you were to call new cheeseburger or new hamburger in your main method, you'd have, like, we can call this hamburger A, we can call this hamburger B, right? You can see this one's rotated and this one is not. So they have each their individual rotation values. So those values are stored in the objects themselves as things go along. And those objects exist in memory from when you declare them until the end of the scope that you're currently in. Now, we haven't currently talked about scope too much, but when I refer to scope, I mean the method that we're currently in. So just keep that in mind. So this doesn't get into static. You can't run any static methods here because these are all methods that these cheeseburgers can perform. So yeah, if we get x and we get y, these should look familiar because they follow the same format as the getter and setter thing we covered earlier this week or last week. So let's see what else we can do. We can move. There's a Boolean is at edge, so this will tell you whether or not it is at an edge or not. Like if you go here and you do is at edge, it should return true. No? Maybe it's only if it's like right at the edge. I'm trying to get that working. There we go. See if that returns is at edge. Boolean is at edge. Man. Well, that does not behave the way I would expect it to. It looks like maybe I'm just off by 1 pixel. Nah, whatever. Not totally worth it. The gist of it is that those are the things that these cheeseburgers can do. So you can see that this cheeseburger has different field values than this cheeseburger. And the way we accomplish that in our code is we have those private fields, and we have those getters and setters that reference those fields. So as the consumer, and we're the consumer here, when we right-click this guy, we don't have access to go and just directly change the x value or the y value. Well, these are the getters anyway. We don't have the ability. In fact, check it out. There is no setter for x and y. The only way for us to move this guy is this move guy. And, I guess in this case, you have to rotate it and then you have to turn him and then move him. So, because I bet if I move him like 50, he's going to move down and to the right. Yep. So the only option for us we can't actually directly set the x and y on these cheeseburgers. We have to turn the cheeseburger and then move the cheeseburger. Now you might be asking yourself, like, why can't you just directly set the x and y values? The answer to that is because you shouldn't have access to it in the most easy use case for this code. When you're making games, it's likely easier to just say move forward into, like if you wanted to go into a circle, for instance, if you wanted like an object to move in a circle, you just have to continually rotate that object, and then you could just say move 1, right? Over and over and over again if you wanted to do that. But if the only option were to set the x and y values, for instance, then you'd be forced to calculate what the x and y value, the next x and y value would be for him to move to. And he'd also have to perform the rotation as well. So it simplifies a lot of game logic if you're only able to move in the current specific direction. So that's a great example, actually, that I did not even plan, because there's no setter available for this. And this is just like using setters in the capacity that we were using them, because we were restricting the people's ability to set the field values. And this is a great example of that, because we don't have direct access to x and y to change it. We can retrieve the current values, But if we want to move this person, we just rotate him and then move him a specific value. So what does that look like in code? Well, what's cool about Greenfoot is that you don't just have access to like a visualization. You can do more than just move these guys around. In fact, if I reset this, that all goes away. And I just run it, and it's just like usual. So reset it again. Let me crack open the hamburger class. I can do that by double-clicking hamburger. It takes a sec, I believe. There you go. And Greenfoot actually contains a pretty cool interface to edit Java code. Now, this wouldn't be what we would use in class nor what you would use in a professional environment, but for learning the code, it's actually not super bad. It's a little janky at times, but it in general works okay. You can see here this green area is where the class is being defined. And this yellow area is where this method is being defined, including the class or the comments that go just above it. So the syntax you can see for creating a class, this is how you make a subclass of actor, but if we haven't done this kind of extension thing yet, so we can kind of gloss over this temporarily. You might be able to guess at it, or maybe you can Google it, and we can actually cover it early next week. We're going to be covering object-oriented programming very shortly anyway. So if you have a class hamburger, we have an instance, well, we don't have an instance. We have a place where we're defining a method here called act. So this is a way to define a method here that accepts no parameters and returns absolutely nothing. That's what the default return type is if you want to not return a value, if you want to do something and return nothing. But let's say we have a field like we had before. Let's say we have a field called Boolean has mayo, right? So if we have mayo, we have a field has mayo. If we wanted to do something like what they were doing with the get x and get y, but not and restrict that field from outside access, we have to make that guy private, right? If we didn't make him private, then code that is running outside of the hamburger class, i.e. this window out here, would be able to see the has mayo and set the has mayo field. But since we made it private, the only methods that can access the has mayo field are the ones that are inside hamburger. Okay, so that way you restrict access to it. So what we've done so far with these private fields is create getters and setters for them. So the getters and setters are publicly accessible methods that retrieve the value and set the value and update the value for these private fields. So note that has mayo, is private, and then the keyword here, well, it's a primitive, it's Boolean. Has mayo is the name of the variable, and this ends with a semicolon. Yeah. I've noticed a lot of people so far have been adding semicolons here, right here. So it makes it seem like maybe there's some confusion about the difference between a method and a field. But with the method definition, we don't need any semicolons. So keep that in mind. And normally we don't have a space there between act and an open parenthesis. We only have this semicolon at the end of a statement or this field declaration here. So we have the field, it's private. Let's make a public getter. So we have public has mayo is a Boolean, so this return type needs to be Boolean. So we'll get has mayo here. And look at me putting that semicolon there. So what we need to do is return the current object's has mayo field. Returns has mayo. Yeah. So remember that the return keyword is what you need to put inside of a method to indicate the return value of that method. So this method is going to do something and then return a value. What this guy says is the value that this method returns is going to be a Boolean. And it's our responsibility in the contents of this method to eventually, in all cases, return a Boolean, either a true value or a false value. So in this case, the logic for this method is non-existent, right? We don't really have any logic. It's just going to be return the current value of has mayo. And this is going to be the format of basically every getter you'll see in the wild. Getters are relatively simplistic methods. They're just there so to give you access to those values. The setter is where things might get a little more interesting. So the setter is responsible for updating this value here. Okay, it's done, and that's it. So if we want to change this value, we need to set it. We need to call the setter. We're not interested in a return type here. Like, we're not interested in the setter like telling us anything after we call it. We're just concerned with it doing a job and updating the has mayo field. So I'm going to say this returns nothing, right? So I'm going to do set has mayo, or I could put this like add mayo to cheeseburger. Oh, hamburger. Add mayo to hamburger. But that's not a good one, because I would probably just set has mayo to true. Let's just stick with the basics here and do set has mayo. Okay. So if we want to set if this current cheeseburger or hamburger has mayonnaise on it, we need to pass the value that we expect to set it to. So this method will accept a Boolean and we can call it has mayo as well. This is a common pattern you'll see, is that the name in the setter is the same as the name of the field. This will happen all across the Java code. So if we have the same name here as we have here, then we can't do something like this. Has mayo equals has mayo. Because inside this method, the scope of this method, for the scope of this method, has mayo is going to refer to this parameter name. All right? So that's like saying like 4 equals 4 or true equals true. It's going to be setting the value of this variable equal to itself, which does nothing, right? I mean, there's no effect when that runs. So what we need to say is this current object's has mayo is equal to the has mayo we passed in. Now that's a confusing little step. If we just put like mayo here, then we don't have to include the this. Yeah. So Boolean mayo has mayo equals the parameter we passed in. So if we pass in true, set has mayo. Mayo is going to be true, and on this line we'll set has mayo, and so on and so forth. But realistically speaking, again, the pattern that you will see, the convention that exists inside getters and setters, is to have the same name, and so you will see this.mayo or this.has mayo rather all over the place. Let me just Command Z this stuff. So now the cheeseburger has a has mayo field. Note the semicolon here at the end. It has a get has mayo here, and it has a set has mayo here. All right? And those methods, again, are not any different than any other method that you would create up until this point. It's just that they follow a very specific pattern called the getter-setter pattern. Okay? So these are the same things that you would do when you define your own methods that perform their own custom series, like sets of logic. Like if you want to write your own method that did anything, it would be exactly the same format. You just these ones are the same thing. They just do a very specific thing that's very common in the Java language. So that's getters and setters. Another common thing that we did cover this week is the concept of a constructor. A constructor, excuse me, is a special method that is run when your object is created. So let's look at, let's make a constructor for hamburger. So let's say that we have to specify whether or not a hamburger has mayonnaise when we first create it. We're not going to let them set that. Well, we will let them set it later, but we're not going to let them create any hamburger without specifying explicitly whether or not that hamburger has mayonnaise. It's a very important concept because people hate mayonnaise, man. I'm not one of those people. I love mayonnaise, but mayonnaise is full of calories, so you kind of got to choose your battle there. But I'm not going to judge people for enforcing this constraint, right? All right, so we have hamburger here. So it's common practice to make your constructors public. So note we have an access modifier here It's valid for class, it's valid for this field, it's valid for all of these methods, including the constructor. What's different about the constructor is that this is a special method that does not have a return type. Okay? So this has a return type of void, this has a return type of Boolean. When you're building a constructor, you know it's a constructor because it has no return type, and the name of this special method is exactly the same name as the class that it's currently in. That is what makes up a constructor. So that's how you know you're seeing one. So if I say public hamburger, and I said to you earlier that I want them to be able to, well, I want them to have to tell me whether or not they have mayonnaise in order to make a hamburger. So I'm going to set this as a parameter. So this is saying, in order to make a hamburger, I'm going to say, you got to tell me whether or not you got mayonnaise, man. So I'll just go ahead and set this.hasMayo equal to hasMayo. You might be saying to yourself, well, that's exactly the same as the setter. And what if I had custom logic on this setter? Then what would I do then? Well, a lot of times people will just call the setter from their constructor. That way, the constructor also respects the setter. Now, that design decision probably is up for debate among senior level developers because that's saying something about the consumption of the setter versus the consumption of the constructor. But we're not going to worry about that for now. For now, let's just say we're going to call the setter when we call this. Now, the distinction between this might not be super clear right now because you might be thinking to yourself, like, why have the constructor if you have the setter? Or why have the setter if you have the constructor, right? And it's true that they do very similar things. So let's go to a different place and not just define our hamburger, but use the hamburger class to build a hamburger object in the code and not just inside the Flappy Bird interface right here. So if I go to the world here, I'm going to crack open my world. I really hope this is recording because that would suck if it weren't. I'm pretty sure it is. All right. So you can see here the code that I have already written for the Flappy Bird project. And I encourage you, I will be sending the GitHub link. I'll add it as part of the YouTube description as well of this code. But yeah, just take a look at it for a while. It's actually super cool to see. I really enjoyed writing it, and I hope you guys enjoyed looking at it. You can see this My World class has a few fields in it, right? We have 4 fields. We have 1 static field. We're not going to worry about that too much for now. But we have act count and score, actor Flappy equals new Flappy Bird. So we made a new Flappy Bird object here. Let's just, for giggles, let's make a new object here. Make a new field, rather. Let's make a hamburger field. Burger bro equals new hamburger. Yeah? Well, see, this is part of why Greenfoot is not super great. Well, actually, it'll tell me there's an error when I come back here. Yeah, there we go. So in Greenfoot, you can see that there's that red box. That's the red box of death in Greenfoot. It means there's a problem with your code, essentially. So let me go ahead and minimize that and go back here. Underline. Now we've tried to look at it. It says constructor hamburger and class hamburger cannot be applied to given types. Required Boolean found nothing. Reason. Actual and formal argument lists differ in length. Blah. That is very verbose. Basically what's saying here is that we can't make a hamburger like we used to. That's the truth. We have to provide it with the data it needs to build a hamburger. Now, this contrived example is pretty simplistic, right? I mean, like, there's no reason why, in this case, you want to just, specify mayo in particular. I mean, there's so many other condiments that you would want to add there. It's just, this is a very common task that you're going to want to use in more complicated situations. We're going to start simple, though. So remember that when we defined our hamburger constructor, we wanted to specify whether or not it has mayo. So we're not heathens, so we're going to say has mayo is true. I'm very clearly in the mayo camp regarding cheeseburgers. I really enjoy it, especially with, ketchup. It's a pretty good combination. It's a winning combination, if you will. So you can see that, specifying the constructor restricts your ability to create burgers and by making you pass it data it needs in order to craft that specific burger. An example I often use in class is that of a cake, right? I mean, if you had a cake class, if you wanted to bake a cake, the things you would need are like, sugar and eggs and milk and cake mix, right? My wife would probably make this like cake mix from scratch, and it's delicious. But I'm more of a cake mix plus milk plus eggs kind of guy myself. So the constructor for a cake class might be, give me 2 eggs, maybe, and we could just write that. Honestly, might be a better class to write. So let's just write it. Hopefully they have a cake image in the Greenfoot framework. Let's see. Food, bananas, bread, flan. That's close. Muffin. I think that's the best we're going to get. So let's do cake. Do icon cake. So let's say if we want to build a cake, well, first of all, I'll make a new cake object. Just want to see it. We got a cake. A bird's going to eat the cake. It's a cherry cake on top. All right, so if we open the editor to edit our cake class, I'm not going to go on here. I'm not going to like freaking make an egg class or a bread class and stuff like that. Hold on one second. South Carolina is not doing great against Gonzaga. Sorry, SC fans. Looks like your run might be over. However, against Duke, they scored 65 points in the second half, so who knows? All right, so if we're going to make a cake constructor, we'd do something like this. We'd have public cake. Remember, it has no return type. We might be like, let's see, we want like a list, an array list, type eggs. We need, not bread. We don't need bread to make cake. We need some milk, and keep in mind these variable names don't have to be the names of the class. I know that's a source of confusion as well. So let's say Ben's eggs, milk, Ben's milk, and then I think it's cake mix, mix, right? And then we would like freaking, I don't know, if there were a class here inside here called bake, it might be like bake, Ben's eggs, Ben's milk, mix, right? And then bake would set those fields or something like that. So in order to, if you wanted to say, give me a new cake, the next thing you would say is like, well, in order to make that cake, I have to like have the ingredients for the cake. So you can think of constructors as like ways to stop people from making things until they have the appropriate fields, or appropriate data to actually properly craft that class. Like if your method that you were writing required a field to be set, you wouldn't want them to be able to make that object unless they had that field value, And that might be a little bit too abstract for now, but we'll cover it again in class. This video is just supposed to be kind of supplementary. So, like I said before, I'm going to go ahead and delete this cake class because it's totally useless. Not to say cake is useless, but in my project it's useless. So yeah. Well, that's essentially what I wanted to cover today. So that we've talked about some sticking points regarding class definition, access modifiers, fields, and methods, and how to define them, and how cool they are, why they use them. So if you have any more questions, just feel free to hit me up on Slack. I think the only thing I didn't really cover in today's video is static fields and static methods. But I feel like we can cover that on Monday, or if you again have any questions, just let me know, and we'll definitely go over it then. So I hope you all are having a great weekend. If this didn't take up too much of your time, again, as always, just let me know if you got any issues. All right? Have a good one, folks. Good luck.